So even though the cable is not pulling anything, the cable itself has some mass density, which they are not massless. So when we have more cable on the winch, let's say we have some, so here's the cable, we have some cable on the winch, then the moment of inertia will be that of the winch plus the cable, and this part will equal to its length on the cable times the radius of this winch and times the mass density. So here is the mass of the cable that is rotating on this winch, and as the winch gathers more and more cable, this L will increase, and then we will have a bigger moment of inertia for this entire system. Therefore, the angular momentum will increase as the moment of inertia increase when the winch get more and more cable surrounding it. So in order to increase the angular momentum, the angular impulse, which is the time integration of torque, will also be bigger than 0. So because we need to supply a torque, this means that we need to supply some power. Or in the other way, we can use the fact that because the rotational kinetic energy is 1/2 I omega squared, and because the moment of inertia is increasing for this winch cable system, the rotational kinetic energy must increase, and that came from the power supplied by the motor. So in either case, we can both tell that this motor needs to supply some power to increase the amount of winch rotating with the amount of cable rotating with the winch.